Hello viewers, welcome back to the channel Think Scalable. Today we will be discussing about solid principles. Now before we begin this topic, I would like to share one instance. When I was in college, I used to think that these principles do exist in theory only and they do not have any practical importance. But but the tables turned when I entered the industry and got to work on real softwares. The software which are dynamically changing every day. You are working on a project, next day the requirement changes, you again do the changes. Now another day client makes another modification, you have to work accordingly. So in a environment where things are changing so rapidly, you have to design your implementation or the code in such a manner that you have to do minimum changes to your existing code base in order to add a new feature. So in those scenarios, solid principles make these messy things work in a efficient manner, right? So there are different principles, like we can see from the full form of solid. S stands for single responsibility principle, O stands for open closed, L stands for Liskov substitution principle, I stands for interface segregation principle, and DIP stands for dependency inversion principle, right? So first one is a single responsibility principle. As from the definition, it is very clear that a class must have only one reason for change. It means it should be atomic. Class should be atomic. It should have only one responsibility. So let me make one thing clear that in while I am discussing all the five principles, I will follow this pattern that first I will take the scenario where that principle is being violated, and then I will apply that principle and we'll see how the things are working, right, on applying that principle. So in single responsibility principle, we have a method, rather I would say we have a class, let's say invoice, right? And there we have three methods. First one is, first functionality is calculate total. Second functionality is your print invoice, and the third functionality is save to DB. So as you can see, a class is having three functionalities, right? Now, what if you get a scenario like, as of now, in order to save to DB, in there you have implemented it using MySQL, right? And in future, the requirement from the client or someone comes that we have to switch from MySQL to Postgres, or let's say MongoDB. Then what you will do, you will go to this method, save method, and update the implementation, right? Then again you are changing invoice class first time. Now let's say in future you have to change, as of now you are calculating the price using some logic X. Now in future requirement comes to update this logic and add a new logic Y. Then again you are changing this class. So once you change any of these methods, you are changing the invoice method. So it is violating single responsibility principle because it is handling three responsibilities: calculate total, print invoice, and save to DB. So it is violating what? Single responsibility principle. This is a clear cut violation of SRP, right? Now we will see how we can uh, implement our code such that it is not violating them. Like earlier it was what, as we can see, three methods were there in the same class. Now we have made the things atomic. Every class will have only one reason for change. Like invoice will be only responsible for calculating the total. invoice printer will be responsible for printing, and invoice repository will be responsible for saving. So that in future, if logic comes for saving to database, earlier we were saving to MySQL, now you want to upgrade to Postgres, so you will have to make change to this method or this invoice repository. So it is having only one reason to change. Similarly, let's say you want to change the logic for calculating total or any discount kind of thing, you will have to change only one class invoice. So only one reason, one class, one responsibility. Now, before I move on to the next principle, I will have to make one thing clear that most of people confuse that SRP states that a class will have only one method or function, but this is not true. There can be multiple methods, right? And still SRP can be implemented. But we have to make sure that all the methods, let's say function F0, F1, F2, these all methods are there in a single class, let's say X. But all these methods should be responsible for doing one single task or responsibility. F1 may serve as helper for F2, F0 may serve as helper for F1. They can be helper function. Multiple methods can be there, but they should be doing cumulatively doing one task, right? So it's not like that SRP means only one method will be there in the class. Now let's move on to the next principle, which says open closed principle. O stands for open, C stands for closed, right? So it says that you have to design the code in such a manner that in future, if you have to add a new feature, let's say you want to add a new feature X, so you have to make sure that your code is designed in such a manner that you will not make modifications to the existing code. Rather, you will use that feature, let's say version 0, and on the top of it you will be building new version v1. This base v0 will be there plus some extra stuff you will add to build the new version v. Similarly, in order to build the new feature v2, you will be using v0 and v1 and extra stuff to build the new version. And this should be the flow. Like, do not do the modifications, extend. You are extending means adding new feature. It's not like that in order to build version v1 you are going to the v0 and making some changes or modification. This should not be the scenario. That's why it is saying it is open for extension. You can extend it from the base version, and you cannot close means you cannot do the modification to the base version. Like we can see in this example how it is violating OCP. Let's say we have a class uh, discount calculator, and there we have a method for calculating the discount. Now if the discount price is Diwali, you will return 10, and if it's a new year you will be returning 20, and otherwise you will be returning 0, right? Now this looks fine. If we look it, but there is a catch over there. Let's say in future you want to add one discount type, let's say Christmas, right? And there we want to give a discount of 30. So if you design our code in this manner, what you will do is you will come here and add a new if else condition, like if type is equals to Christmas, return 30. So what you are doing, you are making modification and changes to the existing code, and which is not allowed under the OCP principle. Rather, what you should do is design your code in such a manner that if new feature is coming, you just extend it. Like here, we maintain a discount interface, and we give the concrete implementations of that interface. Diwali discount, the apply method will be returning 10, and if it's a new year discount, it will be returning 20. Now in future, let's say you want to add the third feature, so you will just provide a new implementation of discount interface, right? What you will do, you will just copy paste, you will make a new class by the name Christmas, right, which will be again implementing your base discount class, and just override this method apply. So you are extending the base version instead of making changes to the existing code. So let's say again a new discount feature, let's say, comes for Good Friday. You will be adding the another implementation. So one thing that should be clear in your mind, that always try to have abstractions, and that abstractions ensure that you have to do minimum modifications to your existing code and you can extend it. So always give preference to abstractions. Keep it in mind. So if I recap the open closed principle, it is saying that do extend the existing functionality and do not modify it. Give preference to doing the extension, extending the base features to build the new feature, and do not modify the existing code base. Because there's a seems like a common sense, but it's not like that. Let's say you have already a stable version is there in the production, right? Version v0. Now in order to add a new feature x, just think like you are changing to the stable version v2 in order to deliver v1, and there could be a situation that when you deploy it into the production, the existing functionality may break. So we have to make sure that we are extending this v1. So in the worst case, what can happen is that our v1 version may not be working as expected, but v0 will be there in the live environment as it was earlier. So this is very important. Now the third principle is LSP, Liskov substitution principle. Right, this is an interesting principle. Why, you will get to know once I explain this. Let's first go through the definition. It says that parent class objects must be substitutable with the objects of the child classes, right? The definition may seem kind of a bit confusing, but it is saying that, let's say you have a base class, right? Let's say we have a base class, let's say x, right? And there are two child classes, y and z. These are the child classes, right? What does this principle says that if you are using anywhere any object of class x and it is working in some manner, now you should design your code base in such a manner that you can replace the object x with the child object y or child object g without breaking the behavior. It means whatever logic was there in the base class, the child should be replaceable with that. Like if I take an example, that I want to say that the child class implementation should not break the base class objects behavior. Like let's say we are taking the example, we have an account class and there are two methods, deposit and withdraw. Fine. And one implementation, or we are extend what rather I would say not implementation, it is extending fixed class deposit account class is extending the base class account, right? And we are overriding the method withdraw in this. Now as we know that in the fixed deposit account the withdraw method should not be there. You can save it in FD. You save your money. You just deposit it for a certain period of time. You just deposit and wait for the return. In between, you cannot withdraw. So for FD account, this withdraw method does not make any sense. So if you would have designed this code in this manner, like deposit and withdraw, both methods are there in the account. So you can see that child class, this is your base class and this is your child class. If you are using any object of account anywhere and it was having two behavior, deposit and withdraw, and it was working fine, but you want to replace this account object with the child object, which is FD account, you cannot do that. Why? Because account was having two behavior, deposit and withdraw, but FD ideally should have only one behavior, that is deposit. So it is violating that principle, that sorry, it was violating the principle. Child class is not able to substitute the object of base class. So let's see how we can ensure that child class should also be able to substitute the object of base class. So if we design in this manner, like in the account class, we will be having only one method, deposit, right? And there we will make sure whether that account is withdrawable type or not. If it is withdrawable type, then only it will having the withdraw method. Now we can have several. The flow is like this: count, it is withdrawable or not. If it is withdrawable, then let's say we have three types of accounts: savings, current, and FD, right? FD account. Now saving accounts ideally can have both the methods, because in the base class you are having deposit method, right? And in withdrawable account you will have the withdraw method. So saving class can use withdrawable. Why? Because base class is giving deposit feature and withdrawable is giving the withdraw feature, and saving accounts can have both the feature. So saving accounts will be extending withdrawable. Current again withdrawable. FD, it will be extending account only. Why? Because it is not having withdraw functionality. So you can see how the changes has been. Let's say in future some new type of account X appear, we will have to just check whether it is having withdraw functionality or not. If it is having, we can extend this thing, and if it is not having withdraw functionality, we can use the account, right? So now these child classes, these are saving accounts, current account, FD or X, these are the child classes. Now if anywhere in the code base, let's say we can see that, okay, I forgot to paste one example. Let's say client. In the client code, you are injecting the account object, right? And you are calling the deposit method and withdraw method, right? So if you want to remove this object of account ACC with either saving account or current accounts or fixed deposit, you can do this, right? So how the code had been structured, that earlier you were not able to do that, but now you have done in such a manner that it is able to handle it. Now let's move on to the next principle, which is interface segregation principle, ISP. This one is very easy. How? It simply says, do not force the client to implement the methods they do not, right? Let's take an example of restaurant, right? There we have waiters, chef, and let's say the one which is handling the bills. So do not design your class in such a manner that in the waiter class you are asking to take orders, calculate bills, and cook. This is wrong according to interface segregation principle, because you are forcing the client waiter to implement these methods: take orders, calculate bills, and cook. This first one is making sense, but the other two are not making sense for the waiter, right? So you should not design in such a manner that you are forcing the client to give the implementation of these two. So let's take one example. Like here we have a worker class, and there we have two methods, worker and work and eat. Now let's say a client robot is there and it is implementing your worker. You are forcing this robot or client to implement both the methods, work and eat. But we can see that for robot, eat method do not have any significance, but we are still forcing it to give the implementation of this. So it is violating interface segregation principle. How we can design it is, we can have two interfaces, workable and the eatable. If it's a human, you will have both the facilities of eatable and workable, and you are giving both the implementation. For robot, you are not this time not forcing to give the implementation of eat, you will just implement the workable, right? So do not force the client to implement the methods that do not use. And the last one is dip, which is dependency inversion principle. It says that high level modules should not depend on low level modules, rather both should depend on abstractions. Earlier I was saying, no, in order, the crux of the solid principle is always have abstraction, right? That will handle most of the part of the solid. Like here also it is saying that, let's first take an example, then I will discuss how it is violating that. We have an email sender, in that we have a send method. Now let's say there is a notification service, and in order to send the email, it will be injecting a bean of email sender and call the send method of this. Now everything is working on, then what's the issue? Let's say again you want to add one new type of notification, which is SMS notification. Then we will write code for SMS sender in a new class, right? Then what you can say, this high level module, this notification service, let's call it as high level module, and this email sender is, let's call it as low level module. Now you can see that this high level module notification service is tightly coupled with low level services, email sender, SMS sender, WhatsApp. So this should not be there. This principle is saying that high level module should not depend on low level things. Rather, low and high both should depend on abstractions or interface, we can say, right? So you can say, instead of depend the notification service depending on the low level modules, it is now depending on abstraction layer, but notification sender. So if the notification service wants to send a notification, it will use this abstraction instead of concrete implementation. It will depend on this abstraction notification sender and just call the send method of this, and based on that the implementation of that notification sender will be used, whether it is a email sender, SMS sender, or WhatsApp sender, right? So now you can see this low level module email sender, earlier it was behaving something differently. Now it is dependent on high level module notification sender. Now notification service, which is high level module, now again depending on abstraction. So now both low level module and high level module both are depending on abstraction, mean interfaces. So this principle says this high level modules and low level both should depend on abstractions. Fine. So that's it. Now solid principle you will get to know more once you start implementing by yourself and start working on some real world project which is changing dynamically. Then you will get the feel, because even after this tutorial you will feel this seems like a theory, what is the use of that, but once you start working now you will start getting the feeling of how important it is. Okay, so that's it for today. Let's meet in some other video. Till then, take care.
Hold me close till I